RCR Wireless News, I'm Sean Kinney here in the Nokia booth at Mobile World Congress 2017 with Houman Modarres to learn a little bit more about Nokia's view on how the telecom industry is evolving. So obviously a lot of big trends being discussed here. Help us share Nokia's view and how these might play out over the next few years.
Well, Sean, it's Nokia's view of the future is of a hyper-connected world liberated by technology. And I guess everybody's vision is roughly the same, right? We want to make the world a better place. And for us, simply we think that a better connected world can be safer, more aware, more prosperous, all around better. So we've made big bets in areas like IoT, cloud, and the path to 5G. We think that if you just look, we have all the tools within this ecosystem. Over the past 20 years, we've connected billions of people around the planet with mobile phones. Now all we've got to do is increase that by an order of magnitude or two to cover the needs of IoT. Over the past 15 years, we've basically democratized the world's information. Now all we've got to do is make it an order of magnitude more readily accessible, right? So it's a really tall order, but that's what makes it really fun. And so we're making these bets in these key areas, and already this week you're seeing some good tangible proof points of progress along those lines.
And two aspects of this massive connectivity are broadband and then the Internet of Things. So can you help us understand how service delivery for those is going to evolve along with the telecom industry?
Sure, absolutely. IoT's been the rage over the past year. You see smart grids, smart cities, smart industry, Industry 4.0, and you see myriad applications all around here this week, kind of at different embryonic stages. But if we take a step back and say what's the kind of key common factors in that infrastructure, really four come to mind, at least to me. One is just the proliferation of the endpoints. The network's fundamentally different as we go beyond connecting people to people. And so this places both capacity and reach requirements, demands on the network, that we have to kind of rethink networks a bit, particularly how we share networks, right? Between fixed and wireless, between licensed, unlicensed, and shared, okay, different hybrid and multi-access technologies. The second is automation. So if these networks are going to be this expansive, then we have to also rethink the way we devise and operationalize networks so they can be more in sync with the needs of these types of applications, far more dynamic. So here we go into our toolkit and learn from the software-defined networking mechanisms to bring policy-based auto-instantiation to these networks so they can essentially be far more responsive. The third is a level of performance and efficiency because the different applications will have very different requirements. Some of them will be super latency sensitive, for instance, while others are collecting data over long periods of time to gather insight. Either way, that's where we'll go into a toolkit and look at things like virtualization and look at how we can disaggregate software and put it in different places so it can scale in and out appropriately, so that not only can the needs of the applications be met, but also you've kind of not broken the bank because you can do it economically, so the feasibility of the applications also kind of stays intact. And then the fourth, which is always the case, but even more in this case, is security, right? So as you get this dynamic, expansive set of opportunities, it also opens the door for bad elements to enter, right? So for instance, DDoS attacks are not a sometime thing, they're an all the time thing. There's millions of them every month. You hear about the 1 terabit attack that happens roughly monthly. So the idea here is we have to look at different ways of analytics and forensics to be able to identify and isolate these threats to make these different IoT ideas a reality at scale. So really kind of the four underlying factors that in some way I think play into most, if not all of these, are exactly those. The explosion of the endpoints, automation, efficiency, and security.
Okay, and so a lot of this is going to be built on that core infrastructure, and I've been hearing a lot around the show about Nokia's vEPC offering, the Cloud Packet Core.
That's right.
Can you help us understand how all of those four categories you mentioned in some way are going to rely on that virtualized infrastructure?
Sure, Sean. I think the Cloud Packet Core is a critical part of getting IoT right, and that's because it's a hub of this intelligent interconnectivity. You see it in some of the new scenarios, use cases, and capabilities. For instance, in hybrid access, where you have to augment wireless access with fixed. For instance, to meet the target or minimum mandated bandwidth requirements, like the EU is talking about 30 megabits per subscriber, that can only really viably be done with some combination of wireless access and some other access. And we've added that to our Cloud Packet Core, and you can see that here today. Secondly, when it comes to IoT infrastructure, CSGN and CIoT, which is in release 13 of 3GPP, that's also been added to our Cloud Packet Core as a key capability. So done right, a true Cloud Packet Core, one that is cloud native, in other words, goes beyond virtualization as a basic tenet, because that frankly won't get it done. That's necessary, but it's not sufficient. You've got to really do the true software disaggregation so different parts of an application can sit where they best belong. It can be sized and dimensioned, lifecycle managed and operated separately. And then you add that on top of a common shared data layer that can provide the resiliency as well as the performance, right? Then it starts to get really exciting, because then you've got the performance across different applications, but you've also got the economic viability, because you're not going to break the bank by misusing network resources, particularly compute resources. So that's when it gets really, really exciting, and that's why I think that the Cloud Packet Core is a critical part of getting IoT right.
Yeah, there's a lot going on there in terms of convergence of wireless, wireline, and then the just overall softwareization of the telecom operator space. So as Nokia works with their customers to sort of understand how to make this long-term transition, what sort of challenges have you seen in moving from education to actual deployment?
I think your question actually hinted at the answer as I see it. Because as exciting as the technology is and as complex as it is, in reality, Sean, the technology is easy when you compare it to change, because change is hard, right? Change is hard, and the service providers and groups within service providers are at different points in their maturity curve in operationalizing cloud, right? Some are quite well there, and others at different points. So that we've seen as a big impediment in adoption of Cloud Packet Core. What we've worked with the operators to do is to package our Cloud Packet Core in appliances, which mitigates that operational risk in the early period, allows them to get started, and yet get to market while they follow that broader operation. Because this software is fundamentally different, Sean, than what they've typically operationalized at scale, which has typically been monolithic systems. In this case, you have, to get the full value, you have to disaggregate. You have to life cycle different components elsewhere. It is an open system where we're taking a component here with a firewall from a different supplier with a load balancer from another and integrating it. So in the end, I would say the technology is interesting and difficult, but really change is the impediment more than technology.
Yeah, and Houman, in some ways, when I think of the end goal of IoT, the vision, I kind of think of it as connecting any device, any object to any cloud application. And to do that, you really do have to be cloud native, don't you, to do these cross-domain bespoke data pipes that are spun up on demand and just tailored for the service requirements of the given application?
Absolutely. And I think a cloud native is the latest of the terms to kind of to go from unknown to overused to hopefully in a number of years, in a year or so, we won't mention it as much, just like we don't talk about SDN in the same way, because it's now been implicitly understood. Absolutely, what cloud native essentially means is that you're designed in a way that gives the right inputs and outputs to work within an ecosystem to provide and get information in exchange to a greater goal. So no one disagrees with that. It's just that's why I said virtualization by itself isn't enough. Just because you took something and put it on software, you can't just throw a party, congratulate yourself and go home because you're virtualized. That's a necessary step, but it's important to do it right. And I think, yes, once that's done, then it paves the way for interactions of ecosystems of application developers, because at the end of the day, in any IoT application at scale, you have sources and sinks of information that are looking to be turned into insight, right? And so for us, we don't look at this journey to 5G as doing it alone. In fact, if you look at our Nokia 5G First announcement last week, it included a large and growing selection of ecosystem partners, massive set of professional services, in addition to our products across the portfolio. So it's truly an ecosystem approach to be successful.
You mentioned 5G first, which has obviously received a lot of attention here in Barcelona. Help us understand the role of Cloud Packet Core in supporting that vision for 5G first.
The Cloud Packet Core is an element, a key element in the 5G architecture and on the path to 5G. And as such, within 5G first, which is a collection of capabilities across Nokia products and services and Nokia's ecosystem, the Cloud Packet Core plays the part of that intelligent control subsystem to be able to do all the information handling, the control plane key elements of making these applications possible and viable. So along with our other products, in coordination with our partners, it's a critical part of our 5G first announcement.
Houman, you mentioned security. I think that Nokia recently made an acquisition that'll really broaden and deepen the approach to security on the network side and on the software side. Can you tell us a little bit more about that?
Absolutely. In fact, Nokia acquired a company called Deepfield, based in Ann Arbor, Michigan, focused on this area of getting insight from what's going on in the network, because in fact, most of the operators face the challenge, as most of the traffic is over the top and video, that they don't know where 70% of their traffic actually comes from or how it should behave. And that doesn't serve well when you're trying to optimize network performance. It also doesn't serve you well when DDoS attacks are an all-the-time thing. So Deepfield's built a very interesting product they call the Internet Genome, where they gather inputs from some tens of thousands of sources in an open system and devise insights from what could be happening in the network and what could be wrong. Nokia is integrating the Deepfield technology into our carrier SDN network services platform to make a very tight operational closed loop that gathers insights from the network, isolates threats, identifies opportunities for optimization, and then close the loop by programming the network to make those changes. So as a result, while we've done certain things in terms of traffic isolation and policy as a first step, this is another step of addressing the very important question of security in the age of cloud and IoT. So we're very excited to have the Deepfield team on board with us.
Well, I really appreciate you sharing Nokia's vision for the future and helping us understand some of these trends that are really going to shape the operator and telecom space over the next year.
Thank you, and I appreciate you and your listeners.
Thank you.
Thank you.